All right. Well, thank you everyone for coming. Welcome. I'm glad you're here. I'm Rachel Freed, and I'm going to be talking about telescope networks in education. And so one of the things that I will be showing is some of the different telescope networks that are available through different programs and a little bit how they're used. Most of the telescope networks, you have to go through a little online program or join some sort of institution that's already using them, but you'll get an idea of what's available for you to use and what's out there. And some of them you can just sign up and start using. So, oh, and there's a bit.ly, which I also have at the end of the talk, which just gives you access to these slides and then the resources if you want. Are you guys familiar with bit.ly? Okay, so I have it also at the end of the talk. All right, so one of the big questions that I often think about is why? Why? And you're probably each here for a specific reason, part of that why. But astronomy is one of those things that is universal, captures the imagination. Everybody has access to skies. Unfortunately, many of us don't have access to dark skies anymore, but there's a lot of people working on fixing that. There's a lot of light pollution. But you might stop a moment and think about what you feel when you look at something like this, and it seems to be universal that people are attracted to the night sky and what's out there and our place in the universe. So that's sort of a why behind all the work in astronomy that I do. So I'm going to jump right in and talk about some of the telescope networks that I'm involved with, and then we'll get into more specifics about what we do with them. But one of them is the Skynet Telescope Network, and this was started about in 2004, so quite a while ago, by Dan Reichert over here at UNC Chapel Hill, and he started with these prompt telescopes. These telescopes were originally designed to do gamma ray burst follow-up observations, but that was a while ago now. They still will do observations to follow up on spacecraft observations and gamma rays or whatever else we're looking at. But it's grown to be a bigger network, and there are telescopes in this network. At any given time, there's 16 or 18 telescopes on the network around the globe. And the thing that they all have in common is they're all controlled by one online portal. And we'll just take a quick look at that. And there's Skynet University, which is great because it's just an online program you can go and do, and you're automatically given some time on this network of telescopes around the globe. You go through their program, they teach you how to use them, and you can learn about astronomy through the use of telescopes. And so here's another picture. These are actually the prompt Skynet telescopes up on this mountain in Chile, but you can see our global distribution of telescopes there. And these are some of the best, darkest sites in the world. And this is a little look into the online portal that people use to access these telescopes, and it's really pretty straightforward. You can add a new observation, you can look up targets, you can click on things, and then you select filters, you select your exposure time. And I'm not going to go into great detail. I'm going to go into more detail on a different telescope network, but I just wanted to give you a sense of kind of the ease with which these are now accessible. One of the things I always love is when you put in your target, you're like, I want to look at this object, it tells you over the next 24 hours or so, oh, it's going to be visible from this telescope, and this telescope, and this telescope, all these different telescopes all around the world, and you get this sort of global sense of where these telescopes are connected and how they're looking at the sky at different times of night and all that. So Skynet also has developed over the last several years, and actually this is Afterglow 1. It's Afterglow image analysis software, where you can do color images, use different color filters and combine them and make beautiful color images of objects out in space, or capture Jupiter and its moons on successive nights and do some calculating about the mass of Jupiter based on the motion of the moons and things like that. Afterglow 2 is currently in development, and this is amazing software, and it's browser-based, so you don't have to struggle with downloading, which is often a problem based on different platforms. But Afterglow 2, I'm actually in meetings where they're adding new features all the time, and it can do things like if we are taking exoplanet observations where we're measuring the change in light as a star has its little planet go in front of it, it can measure the change in brightness and create light curves. It can create light curves for variable stars and do period folding. All these really amazing techniques just are being built up along with the telescope network. And really cool, going along with that, there's one radio telescope on the network now. So it's not just optical light, but also radio. This is a huge dish, 20 meters, and this is on the Skynet network. And I will say more about radio telescopes in a moment. So one of the programs I'm involved with actually is super cool. It's developing and implementing around the country, actually, in community colleges and universities all over the country. We have about 35 to 40 different institutions involved in our pilot program, but we're developing a curriculum. Imagine you're taking your Astronomy 101 class, but your labs, all of your labs are like, okay, we're gonna study the Galilean revolution. Let's go actually use telescopes that the professionals use. Let's go to the online portal. Let's get our own data, our own images, and do our own analysis. So we teach students how to use the telescopes, about different color filters and combining the different images, the different color images to make a colored picture. And then we have all sort of the standard aspects of Astronomy 101 curriculum, but telescope-based, where students are collecting their own data. So studying Jupiter's moons, Cepheid variables, the distance ladder, where we use different objects to measure things at different distances in the universe, studying our place, actually, in the galaxy, within our own galaxy. So there's, oh, sorry, I'm walking out. So in studying Hubble's law, the expansion and the acceleration of the expansion of the universe and dark matter, all these classic Astronomy 101 curriculum pieces, but now we're using telescopes and collecting data, and that is really fun. In development, actually, which we just started this year with a new grant, is another program called the Multiwavelength Universe, where it's sort of the next step in astronomy. So let's now also do radio imaging and combine that with optical imaging and study the universe in different wavelengths. Let's look at objects in different colors and make an HR diagram. Does anyone know what an HR diagram is? Oh, a Hertzsprung-Russell diagram. Okay, I'm just gonna say, go look it up. HR diagram online, it's amazing. One of the best graphs in all of science, in all of history. It basically tells us everything about the life cycle of stars, from the little tiny red dwarfs to the big massive O-type stars that go supernova at the end of their lives. Exciting stuff. I'm not gonna go into more detail about it now. So we're developing this curriculum. Again, it's totally telescope-based. And one thing I want to say about these telescopes is these are the same telescopes and the same online portals that professional astronomers use, which is really cool to be like, oh, I'm just like Dr. So-and-so, I can go collect my own data. All right, so taking a step down from that big telescope network is MicroObservatory. This is one where you could just go online today, sign up for an account, it's free, and start playing around with it. It's smaller telescopes. There are 5 of these 6-inch telescopes around the US. And they're all controlled through a portal again. And this is a NASA program. And they have things like do-it-yourself planet search, where you can go online and you can actually collect new data, and they teach you how to do the photometry. So they show you, there's these really great tutorial videos that teach you how to measure the light of the star with the little planet around it that you're interested in studying, and how to graph that changing light and make a light curve. They have all kinds of really cool tools, and one of the things I love about them is their online tutorials. They really teach you the heart of the astronomy techniques that we use to study things in the universe, and you can collect data with those telescopes. I will say they're smaller telescopes than the Skynet that I mentioned and the next one I'm going to mention, but they're still they're able to capture exoplanets and really cool phenomenon out there. Here's some of the things from MicroObservatory. I mentioned the do-it-yourself planet search. So they teach you about finding comparison stars in the different images and measuring the brightness of comparison stars to see how the brightness of your star of interest changes. They have tutorials on teaching you how to manipulate astronomical images, because often when you get an image back from the telescope, you look at it and you're like, that's ugly, or I can't see anything in it. But if you just change different brightnesses and scales and whatnot, you can bring out incredible objects like galaxies and nebula and really amazing things. So MicroObservatory is a really great place to start for a lot of fundamental astronomy. They also have created an astronomical image display system that teaches you and you can use to add color images. So when we make color images, we use a different filter, a red filter, a green filter, and a blue filter. And then we combine those to make a color image. So they teach you how to do that. You can import your own images from other telescopes or from the images you get with their telescopes. And they teach you how to manipulate them. And that's really cool. Also browser-based, which is great. Great Basin Observatory. So this one is less accessible to the public. However, it is a really great example of a cooperative agreement. So these are 4 universities that together paid to have this really amazing observatory set up in Great Basin National Park. And they have students doing research, publishing their papers. So students from these different universities, I've worked with some of them, and they're always open for collaborations. One of the big things that I'm really interested in this global sort of community we're in is building collaborations, either locally or state to state or country to country or all the countries. So there's a great story about this one. The dome control system and a lot of the underlying technology that allows all the different parts of a telescope to communicate with each other. These were developed by a guy named Bob Denny from, and it's ACP software. And when this telescope was first built, I was at a conference and I was sitting with him and I said, I would love to learn how to control ACP, the dome control software, and how to use this telescope. And this was at a conference at the bar afterwards, and he was like, well, let me show you. So we opened up the computer, we went online, and he logged me into the telescope, and I was able to access the telescope in a different state and take pictures, and I learned how to use it. And the next day, I was going to Concordia University to meet with students, and I was able to show them how to access it, how to collect data. They did, and a couple months later, they published this paper, an astrometric observation of binary star, WDS, etc. And that's cool. I think that was the first published paper that came out of that observatory. So a lot of the work that I do and what I would encourage everyone here and everyone listening to think about are these collaborations and getting to know people and interacting and collaborating with sort of whoever's willing to work together and teach you and learn from you. So that's exciting. Mount Wilson, this is not a telescope network, nor was Great Basin Observatory, but I think it fits along with all the work that I do because we've run research programs for students up here for the past couple summers, and in 2022 we're going to have another seminar, and we're actually not too far from there here. We're a couple hours away, but we bring students up and they get to use the 60-inch or the 100-inch in that dome. These are huge telescopes. Can you guys show me 60 inches? See, 36 is a yardstick. These are huge. This is the diameter of the mirrors. Or the lenses, or whichever type of telescope we're talking about. These are huge telescopes. And so we bring students up there and they actually collect data and get to publish their data and learn how to do research. When each of these telescopes was built successively, they were the largest telescope in the world at that time until the next one was built, and then that was the largest. And this is a team of high school students, actually, 2 years ago. Yeah, they came up there. They did some research on the 100-inch, using the 100-inch. And one thing I should note, I mentioned in the very beginning, why do we do this? Just sort of the majesty of astronomy and the way that it just sort of captures our imagination. Well, the first author on this paper, Elizabeth Phillips, was also an artist, apparently, and she did a painting. She was inspired by her visit there, and she painted that, which I think is just beautiful. So we really have this more than scientific connection to the night sky. So that's Mount Wilson, which does programs for students. All right, and now to I guess my favorite, the big one that I'm going to go into more detail on, Las Cumbres Observatory. So this is another global telescope network. You can see those dots represent the sites where the telescopes are. They are 0.4 meter and 1 meter and 2 meter in diameter telescopes in the northern and southern hemisphere. What's different about this compared to Skynet is Skynet actually, and I don't think I mentioned this, a lot of those telescopes are owned by individual institutions or individuals, but they all get on the same portal. Here, these telescopes are all built the same, with the same cameras, the same mounts, everything is the same, and they're all controlled by the same online portal. When they break, we know how they break, and if the next one breaks, we can figure that out because we already fixed the last one. So, Las Cumbres Observatory has an amazing global partnership for education program. And this started about 4 years ago. They have over 22 institutions around the world in Nepal and Nigeria and South Africa and, well, oh, there's a map of all these places. All these places are the headquarters of organizations that are education partners with the Las Cumbres Observatory, which means those institutions and their students, have access to these telescopes. I am one of these dots. My Institute for Student Astronomical Research, which is a nonprofit that I started a couple years ago with some other people, we have access. We get to use these 0.4 meter telescopes all around the world, which is kind of incredible. These are the same telescopes, just like with Skynet, that the professionals use. And in fact, how many of you have heard of gravitational waves? Some people. Oh, gravitational waves, another thing to go Google when you get home. But so gravitational waves, the discovery of them in 2017, I think was the first one we detected, are this whole new way of understanding the universe. You know, pretty much everything else we've studied in astronomy in all of the thousands of years we've been looking at the sky has been on the electromagnetic spectrum, visible light, and then we went into ultraviolet and infrared and everything else that we may have learned on the electromagnetic spectrum, gamma rays, microwaves, radio waves, etc. Well, gravitational waves, hypothesized a long time ago, Einstein hypothesized gravitational waves when you have two neutron stars or black holes near each other and they start being gravitationally bound and spiraling in towards each other, when they finally collide, they just generate this huge amount of energy and create these ripples in space-time itself. It's not light. It's actual movement or movement. It's a change in the fabric of space-time, if you will, gravitational waves. And we spent, I think, 40 years building the detectors that could detect these, and we finally found them in 2017. So amazing. Now we've found lots of them, from neutron stars colliding with neutron stars, black holes colliding with black holes, etc. These telescopes were some of the first to do optical follow-up observations. So we're like, okay, there's a gravitational wave being generated right there. We just detected it. Everyone who can hear us, take your telescopes and point it in that general direction, and let's see if we can find something visible that matches that gravitational wave. And these telescopes, some of these telescopes got a lot of those initial observations where they did find an optical counterpart for gravitational waves. So amazing. You too can use these telescopes. So this is the Las Cumbres Observatory telescope network. This is what I use with a lot of my students. And it's pretty amazing to know that we're using the same kind of equipment that everyone else is using. Yes?
So you would have to put in a request with the LCO, and then you could observe it?
So actually, you would have to become involved with one of the education partners. And so, which is okay, I see that, oh shoot, sort of look. I will say, if you know me, you can get involved, and you now know me. So there's a way to get involved.
Okay, so my next question would be, what kind of data would you want to pull? Like you would want to kind of know, like, I want to know the gravitate or the distance or the size.
Right. So gravitational wave follow-up is not a field that I'm involved in or work with, but I'll show you some of the projects that my students do where we collect data from these telescopes and publish papers on. Yeah, that's a good question. So what on earth do we do with these telescopes? Let me just run through how simple it is to actually use these online portals to collect data. So I did this last night. I just got screen captures in case the internet was not working. The internet's working, but actually it just works well to show screen captures. So I just typed in, I'm going to call this observation that I'm requesting the DART launch demo, and I selected, this is my proposal, astronomy research seminars for high school and college students. And that's all I put in the first part of the portal. The next thing I put in, I select that I'm going to use this telescope. That's actually the only option, the 0.4 meter telescope. We don't actually have access to the 1 meter and the 2 meter, but 0.4 meter works for most of what we do. I select how many pictures I want to take and how long I want that exposure to be. So 60 seconds, one picture at 60 seconds in this case, and a filter, the Bessel V filter, so that just tells it which filter that's closest to just sort of normal visual range. And then I was like, what do I want to take a picture of? I want to take a picture of the Orion Nebula because I love it. So I typed in Orion Nebula, and it actually did a search and was able to say, oh, I know where the Orion Nebula is. I can set it to take those pictures. It found its location, right ascension and declination. It also said 7,109 existing frames have been found in the Science Archive. So one thing that's really cool is you have access to all of the science archives, everything that's already been taken. So thousands of people use this. So you might think you're going to start out to look for some cool image and take a picture, but then you're like, well, there's already 7,000 of these. I'll show you one. That's someone's. That was like one of the first ones. I just grabbed it off the Science Archive, and it's pretty beautiful, but that's just a quick and dirty. You can really go into a lot more detail if you do longer exposures and different filters and combine them. That's just pretty stuff, though. That's not the science that I'm doing, but I just wanted to show you sort of how that's doable. The telescope, just like with Skynet, it says over the next 24 hours, it's going to be visible from Siding Spring in Australia and Sutherland and McDonald in Texas and all these different telescopes, Haleakala in Hawaii. Like this is sort of showing it will be visible, that target that you chose will be visible at these different locations, which is plenty of locations. And then you hit submit request, the green one. And it sends off that and gets your observation request in the queue, and then you get an email that says your observation's done, and you go and you download it, which is pretty amazing technology. And I'll come back to the projects, the research that we do, and get into that. But I wanted to always come back to the sort of global nature of this and the global community, because one of the things I've been in astronomy, well, I've been in astronomy outreach for 21 years now, but I'm involved in quite a global community, and it's really amazing what we can all do together. And I was actually in an LCO, that's Cumbres Observatory meeting last week that we have every month, and each month they have a little speaker. One of the partners, education partners, takes 15 minutes to talk about their project. And this guy from Paraguay came on, and this student had gotten to use the telescopes, and he became so excited about it that he started up all of these observation programs in his home country of Paraguay. And so I just grabbed some shots from their Facebook page, but I noticed in scrolling through, they were talking about Mission DART. I was like, wait a second, I'm going to be there. And it was just really cool just to see, and they're interested, they're studying asteroids. These students in Paraguay, because they got to use this global telescope network, and I got to hear about their project from my little house in Sonoma County. And then here I am 5 hours away talking to you guys about it. It's just really cool. So they do a lot of research actually now on asteroids, and they have, they started a workshop, and they have 50 people registered within a couple of weeks. I mean, people just have this interest in astronomy that can really be leveraged for science education and global community building. Okay, so back to your question, like what would we do with these telescopes? So I work with students just to get an introduction to astronomy research. JDSO is the Journal of Double Star Observations. These are students I worked with last summer, I think. And we decide on a double star system to choose, and we have tools to do that. I give them the tools and show them how to do it. And then we collect images from the telescope, and we do really simple measurements on a double star, where they are in relation to each other. And we can look back at 100 years of history of measurements of where those two stars are in relation to each other. And if we chose a good one, we can see some movement, and we can say, oh my gosh, that star really is orbiting. Or we can say, you know what, they thought it was orbiting, but now it's just continuing on in its straightish line. It's not actually orbiting. So we can contribute to the science of double star astrometry, it's called, and publish our research, which is really exciting. It's a very small niche of science, but it's great for students to access, to learn how to write for science, to learn how to read science literature. This is the Journal of Double Star Observation from November, so a year ago, and all the ones with yellow stars up there are student publications. So you can see students are really contributing to this field. It's not just one or two, it's having a big impact. And what I love is, for me personally, looking back at this, and I'm like, oh look, we're here all on Zoom. We were doing this on Zoom, by the way, before the pandemic. So lots of people whose internships were canceled in 2020 came to us looking for research to do. So we got, actually, our program increased a little bit. But we start off with students who have never used a telescope, never done an astronomy class. Some have, and some students are astronomy professors at a community college. Some have been teaching astronomy for 20 years but never done astronomy research. Some are high school students that are really enthusiastic that we bring these groups together and they work in teams, and by the end of an 8-week seminar, they've written up their results in a paper that gets submitted to the Journal of Double Star Observations. It's gone through lots of review, but eventually usually gets published. So if that sort of answers your question, what might one do with telescopes? You can measure double stars. There's lots of other types of projects. This is the one that I'm involved in, which has nothing to do with gravitational waves that I had mentioned earlier. So just to kind of highlight the value of this is real science writing, this is real publication. These are real papers so students learn how to write. And in fact, for several years, I've been doing research on the students that do the research. And I'm always surprised, the number one thing students say that they got out of the program. Anyone want to guess what's the best thing you could get out of doing a double star astrometry research program and using telescopes? The number one thing is learning how to write. I would have thought it was like, I got to use a telescope, I got to take pictures of stars. But the value in learning, because scientific writing is so much different than any other type of writing, and it's really not taught in school. You don't usually learn how to do it until you're in grad school, and then it's a big struggle. I'm in graduate school, by the way, and it's still a big struggle. But I've had lots of practice. You go through revision and revision and revision. I think the most revisions we ever had was 14. So can you imagine you get your paper back 14 times? Like, not good enough, not good enough. But eventually, you get something that says your paper was reviewed and has been accepted as is for publication in the JDSO. Yay! So we publish a lot of student papers, and I'm really sort of proud of the statistics that have grown up out of the last 10 years of these kinds of programs. These are the number of student research papers in the Journal of Double Star Observations by year, and you can see we're doing, even in 2020, awful pandemic year, everything was terrible. We still had 32 papers. This year we've got 30. We would have had a few more, but we had one special issue of a really long paper. But still, that's pretty good each year. And what I like even more is the percentage of JDSO articles contributed by students. This really shows they are having quite an impact on the field. And in case they're wondering, students sometimes wonder, like, okay, but whoever reads that? So these papers have to be published in order for their measurements to get into the Washington Double Star Catalog, which is maintained by Brian Mason at the US Naval Observatory. So our students actually email Dr. Brian Mason and ask him for the historical data, and then I let him know when new papers have been published, and he goes in and gets the data off those papers and puts that into the Washington Double Star Catalog. So it really is contributing to science. So, all right. I want to let you know about a couple other programs. If you're interested in getting involved, or your students are interested in getting involved, Our Solar Siblings, which is run out of Australia, has this really great program taught by Michael Fitzgerald. That's him in the corner there. And here they don't do double star astrometry like what I'm used to. They do variable stars, our Lyra, and variable star research, but they also use Las Cumbres Observatory Telescope Network. So if you're a student and you're like, I need to get involved in astronomy, how do I start, what do I do? You go online, you go to Our Solar Siblings, you can sign up and take They're online Moodle courses at your own pace. It's self-paced, teaches you how to use the telescopes, how to figure out what stars to even observe, how to analyze the data. And it takes you through that whole program. So you can do our Lyra observations and publish that work. This is another journal that's Astronomy Theory, Observation, and Methods. This is sort of a really good, high-quality catch-all for a lot of research that can't be published elsewhere. Yes?
I didn't catch on the previous slide.
That's okay. OurSolarSiblings.com. So, awesome. A lot of research, for example, exoplanets. Everyone knows what exoplanets are, planets going around other stars outside of our own sun, right? So there's a lot of study on exoplanets, even though it's a fairly new field, 1995 or so when it first started. And in the beginning, it was amazing. You're like, oh my gosh, I just measured an exoplanet published in this great astronomy journal or that great physics journal. But now it's sort of run-of-the-mill, everyone does it. But we still need to keep track of that information. We still need to document and put it into the databases and all that. And so this is where, if you're a team of students working with professors or whatever, you can't, then that actually is a professor-student, college student team that did this research. You can publish your work in this journal. So, all right, another telescope network, that's an interesting one. This is not one that you go access. This is a telescope you would have to buy or your school would have to buy. Hint, hint, administrators. But it's this eVscope, and I don't know if anyone's familiar with these. These are really new, just the past couple years they've been developed. But, and it's by Unistellar, and there's another one that's similar. But it's, what it does is you point it at some object in the sky, and it's got GPS and all that, it's automatic, and it, as you're looking in the eyepiece, there's a computer chip in there, and it builds the image up over time. So it's sort of, it's basically integrated a camera with a telescope. And so you can get amazing images, even in light-polluted skies. And these are becoming more and more popular, and the images, they're on computer chips, and the images all get stored by the Unistellar company. And so they have access. If you imagine thousands of people have this telescope and thousands of people are taking images of whatever, all that data is being collected and can be used for research. Don't try to read this. It's just an example of a poster from the Unistellar folks, but it's people, the network, a networked telescope. So it's, even though it's not technically like a network, it actually is, because all of the data goes back to a central source. And so they've done exoplanet studies here by combining the data from random people that own these different telescopes. I had this in my slides, and then just yesterday, a friend of mine on Facebook, I'm a big fan of social media when used for the greater good, woohoo, just received this image of a relativistic jet emanating from the supermassive black hole's center in galaxy M87. This is a compilation of images taken over a 2-week period in July by 40 amateur 4.5-inch Unistellar telescopes. So 40 people had that telescope and were taking this image, and they're able to take all that data and combine it. And this is M87. This is the galaxy that we used a planet Earth-sized radio telescope, essentially, to take our first ever image of a black hole a couple of years ago. And this is that galaxy. But you can see a little relativistic jet coming out there. So this is exciting. This is sort of a network of individual telescopes. So if you can get your institution or your institution to collaborate with a couple of institutions to get one of these telescopes that you can then use, here's another way to access the night sky. Another one, if you are just like, I just want to use this telescope a couple times and get a couple cool images to show my friends and family, itelescope.net, you can just pay, you kind of pay by the minute depending on the size of the telescope. You pay a different amount, but literally just go online and you can rent a telescope. They have them at really nice dark sites in Australia and Spain and New Mexico and California. And they have lots of telescopes in each of their buildings. We used to use these for my student research programs. So that's another sort of network of telescopes that's accessible for education and the public. There are lots of challenges we always have to be mindful of. Maintaining equipment, maintaining programs. For the past 25 years, there have been programs that started up with people saying, oh my gosh, just give us access to telescopes, and of course we'll use them, and all of our students in all of our county will use them. And many programs like that sort of came to life and then petered out and nothing ever happened. But we're now at a time where the ease of telescope access has really made it possible for all of you, all of my students, to access these telescopes. So it's really changed in the last couple of years. So that's great. So maintaining programs has become something that's easier to do and something that I'm dedicated to doing. I build programs, and then it's important to me that they are sustainable. When I teach teachers, I tell them I will help you forever. If you have questions, what did we do that second week of class? Come back and I will show you how we selected a star to observe or whatever. Communication problems with the Max Dome hardware. There's always hardware, software, talking to each other problems. Or the temperature is 24 degrees. It appears we're back online after Kev went out and braved the 24-degree temperature. So there's weather, there's technical issues. I see this all the time with the observatory that I volunteer at, and we see this with LCO. Or this site is temporarily unavailable due to the local fires. Are you all from California? Yeah. Have you guys had fire issues? Maybe not locally. I'm really glad for you.
Well, they just recently had a controlled burn.
Oh, a controlled burn.
Over at Pismo.
At Pismo, okay, okay.
But
No major forest fires. So lucky.
My daughter had two in Mendocino County.
Yes, Mendocino.
5 miles from their house.
Yeah, it's a big problem.
Yeah.
It's a big problem. It's a big problem that's been a part of my life. Monday, October 9th, it started a couple 10 miles from my house. I was actually up at the observatory. This is my local observatory. I was up there that night and driving down the hill. And I was like, what is this wind? I took a picture while I was driving of the leaves and everything blowing. I had never seen wind like it. 2 hours later, my friends tried to go down from the observatory. The whole road and trees were on fire. They couldn't. And that started a series of events that wasn't just my local observatory. This one 20 miles away where I was working, our observatory, the dome and everything inside survived, but everything else, the infrastructure, the electricity, all burned. Mount Wilson, same month, fires. It didn't burn Mount Wilson, but boy, did it get close. Dan Reichert, that same month, I mentioned Dan Reichert who started Skynet, someone started a fire on his campus. Or there was a little fire by a tree. He went to try to put it out. Turns out there was like a little bomb there, and he got injured and sent to the hospital. Yeah. I was like, well, at least I have access to Las Cumbres Observatory Global Telescope Network, right? You can't have telescope network, a whole network down. Well, due to the local wildfire, the office that controls them in Santa Barbara was closed. I mean, it was crazy. You know, here we are, Santa Maria. Anyway, that was 4 years ago. Oh, wait, we've had fires every year since then. This was in September by my house. There's me. This was 1 week, fire, 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 smoke. Anyway, it's a bad problem. It's a global problem. And bringing together a global community is sort of one of the ways we can start to address the issues that we have on our planet. And astronomy is one way to build that community. I'm part of programs involved with the International Astronomical Union, and one of the things that they do is they have an Office of Astronomy for Development where they actually use this passion that we have for the night sky, this intrinsic value of, of looking at the sky, and that's shared all around the globe to help underdeveloped countries sort of build infrastructure and come together and get support globally. Also, their Office of Education opened up just 2 years ago, and they've come up with this big ideas in astronomy, which is really like, what does every adult scientifically or astronomically literate citizen, what should they know about astronomy? Anyone have any thoughts on that? As an adult, when you're an adult in this world, is there anything you should know about astronomy, just to sort of be literate. E equals mc squared. Yes, and maybe how to apply it. Newtonian is good enough, right. But maybe understanding our place in the galaxy, our place in the universe, understanding what planet Earth is in relation to the sun, understanding maybe a little bit like when I look at that night sky, that's Jupiter, Saturn, and Venus, which have been up every night recently, in case you've looked up, right? But all those other things are distant stars, right? And just sort of having a little bit, anyway, so they've sort of built this literacy of astronomy. So they're really working internationally, globally, to build this community, which I think is a really important part of what astronomy is. So I want to thank you for listening, and I hope that what you get out of this is basically that there are programs that students can get involved with, students and teachers. I keep mentioning students, but I want to really emphasize that I work with teachers and students together. Most of the published papers that we have from the past 5-6 years are teams, collaborative teams with students and teachers. I've had people from like 5 different institutions all on one team together, and it's really working together that we can learn the most and do the most. But and we're sort of a global people, and so I want to thank you all for being part of my community and for listening to my talk. And I would love to answer questions because I feel like there might be questions about accessing telescopes in research projects. And if there are, I would love to answer those or just say thank you. So thank you. The end. Yes.